right, good afternoon, or I guess good evening. Uh, What we'll do is we'll start out tonight, we're getting into 10.4. We'll do a little bit of review over any questions you might have in 10.1 or 10.3, because typically the lectures will last 30 to 45 minutes, so we have time. We use that time at the beginning to answer any questions as we go through from previous stuff. I think the homework actually was did I move it to Monday night? Does anyone know? I think it was due yes.
So I completed it before the due date.
Good.
Do you get, it shows extra credit.
Yes.
Do I actually get to keep that?
Yes. So that's, what they've done instead of penalizing you for late, what they're doing is this: if you finish at a date 24 hours early before the due date, you get 5% extra. So that'll be so that's the extra credit. That's why, and so I don't mind moving the due dates, but that's kind of why we have to have it. But what that also means is if you're behind, what I can do is I can place an exception if you didn't get it finished. So since we do one or the other, so we encourage you with extra credit rather than penalizing you with demerits or not getting it done or something. So if you didn't get it all done, send me an email. The best way is to send me an email, because then I can see your name and I can do the exceptions. Okay. The other thing I do is I look at, as long as you're getting, now for the extra credit, yeah, you have to get it. I think it's all done, or I'm not quite sure how, but I think as long as it's finished 24 hours, you get the 5%. The other thing I do is I will go back through, and if you get to, let's say we'll start it with 90%, because there are a few things where, in fact, I was working with someone, we were coming up with the right answer, it wasn't accepting it for some reason. I looked on my system and it said that was the right answer, so I don't know why. So there's occasions like that, so I'll round up, so if you got 90%, it gets, you'll see 100% in the Canvas gradebook. And I'll do an update to the Canvas gradebook, because Canvas is actually our official gradebook, but all I'm doing is copying the stuff over and putting it in the percentages and those kind of things. So, but the goal really is that you get through it, whether it's on this time or whether it's a little bit, as long as we get to this exam and you're able to work through these things and understand them, you'll be able to do well in the review and do well on the exam. And so we'll make it all work. Yes?
Sorry, I can't remember if you said this or not, but are the review quizzes for points? Or do they not, are they just?
Yes, they are. And in fact, I can't remember in this class there's a percentage. And so what I've decided to do in the syllabus was originally that there may be quizzes and they might be in class or this or that. We will have them. I will use all my quizzes as reviews. So those will help you review for the test, and then as you complete it, and they will really be completion, because you'll have multiple attempts at them till you can get all the points for those. Because I find the more times you do it, the deeper it's learned, and so we'll make sure that all works. Okay, so we've got that going. Let me see. It's important, now by the 19th, today's the 17th, right? So that's Thursday. You're supposed to have at least gone in and done assignment 0, and that's mostly what they're saying is that you have to have started engaging in the class, right? So assignment 0 does have some things that help you understand how the system works, but it's not for any points. You don't necessarily have to finish it, get it started. But also, if you started into 10.1, that's similar. So it's just be started, registered for the course, and started. So the first thing I do is I look and see who's in Canvas, and if someone's in Canvas but they're not here, they haven't registered for this part of the course, then that's when I would do an administrative drop, because maybe that person, something came up and they're not going to do it, so then they don't have to pay for the course, right? But if you haven't gotten access to this yet, if you're in here, you're fine and should be making progress. But that's the main thing of the administrative drops, is sometimes someone didn't make it back to campus, they forgot about us, and then if we don't do this, then they get charged full tuition. At the end, the only option I have is to issue a grade of E, and so it's not good. So it's better to administratively drop them. They don't get charged. They don't get a bad grade on their GPA. But if it's just that you're working on getting things together, let me know. Keep in contact. Okay. But there was a few people who mentioned that they had some questions on some of the homework, and anyone have a particular homework question they want to take a look at, either from 10.1 or 10.3? No? Oh, yes, sir.
Just 5 and 6.
5 and 6 from which one?
D5. Or 10.3.
From 10.3, okay. Yeah, so yeah. Oops, I gotta go to 10.3. Let's preview. Oh yeah, okay. So this might throw you because of all the extra letters, but these letters are really, they're just numbers. So if they were numbers, what do we get to do? Remember, we basically ignore everything except the upper limit here. And then this one is a squared, so we ignore these things. Yes, I gotta be careful. These are both negative, and the limit is going to negative infinity. So x squared, when you square a negative number, what do you get? A positive. So this top is going to be like negative a squared b over x squared. The bottom is going to be like negative ab over x squared. So it's just simplifying. We get to ignore everything else at infinity, not just in general. But at infinity, this is true. So negative divided by negative becomes positive. B divided by b is 1. X squared divided by x squared is 1. And then a squared divided by a is going to just leave us with a. So that's... Now these ones, let's see, this should give you, 1, 2, 3, 4, 5, 6. When they give you these multiple choice ones with 4 or more, I think you get either 2 or 3 tries. So if there's only 2 or 3 multiple choice, you only get 1 try, because especially if there's 2, then you know the right answer. Again, that's why I do the 90% for it. As long as you are learning from it, we'll make it work. If you have some concerns about how it's going to affect your grade, I think the whole homework is only like 10% anyway. So we can work with it. The main thing is if you're learning, we'll make sure you get all those points. Does that help? Okay. And then the one below is similar. It's also going to negative infinity. Again, we just pick the largest degree, the largest exponents. This one, the bottom is x to the 3rd, and this is x squared. So when they cancel, again, there's also some stuff up here, but it's going to act like something over x with, I don't know, these will cancel out and whatever they're going to do, but as x gets big, this whole thing's going to go to 0, right? So it really doesn't matter what's left in here. Yeah, you'd have an a in the top, the b would go out, so it'd be a over x, but as x goes to negative infinity or positive infinity, it's going to go to 0. Okay, comes just... Is that... Okay. Yes, sir.
Number 18, please.
18? I didn't realize they gave you that many. Wow. They did. I did, I guess. So, okay. Let's see what we're doing here. Okay. Oh yeah, I remember looking at these. Okay, annual U.S. imports from a certain country can be approximated by this equation here. And then, which is in billions of dollars. And then that is for U.S. imports, and then I guess this is what, U.S. exports. You notice I don't like to read too much, so so we've got these two things. And then they're going to, so this is a quadratic, right? It's telling us t is good for 0 to 9. This is 0 to 10. Assuming that the trends shown in the above models continue indefinitely, calculate the limits. So this is what we do in business. Sometimes if we just want to say something's indefinite, we use infinity. Now usually we're thinking of infinity as a very, very large number, but in business problems, oftentimes it comes up, we use infinity for indefinite because we don't know when that is, so we see how far out we go. Well, if we let t go to infinity, what's going to happen with a quadratic? It's going to open up, so a quadratic will look something like this. So as x goes to infinity, the y value is also going to go to infinity. Okay, so this one should be infinity, and this one also should be, now the question is though, what happens when we look at the ratio? And again, what we're going to do is we're going to take the I over E, so it's all we're going to look at for the ratio part are the largest exponents. So that's going to be t squared over, in my case, 0.2 t squared. Again, the t squares will cancel, so that's going to be 1 over 0.2, which is 20, 2/10, 1 over 2/10, reciprocal. Did I get that right? 0.2, I think that's right. But sometimes when I flip things, so plug in your calculator, do 1 divided by 0.2, I think you get 20. So indefinitely, the ratio of the imports to exports is about at 20, the trends. And the long-term U.S. imports from other countries will see, so drop down, rise without bound, be bounded. The U.S. imports, so that's the I, so that's this first one. It's going to rise without bounds, right? Because it's going to go to infinity. And be blank times U.S. exports to other countries. And be, so then that's the ratio. It'll be 20 times. Yes, sir.
Isn't this supposed to be 5?
0.2. Yes, that's what I thought. Sometimes I trick myself. 0.2. It's one. It's 5. Okay. That's why sometimes just pull out the calculator. Good. See, never trust me on a calculation. Follow through. Good. So 5. So then, yeah, 20 sounded a little bit big. So then in here, it's going to be 5 times as big. Imports will be 5 times as much as exports. Okay. Could the given models be extrapolated far into the future? I don't know. I guess they could, but I would say just knowing economics, probably not, because things change, right? So I wouldn't trust it for more than maybe 10 or 15 years, even if that. But I would say no. I'm not sure what it's going to. I would say no. Let's submit it. Oh, I didn't put all this other. Let's see. Let's try this. Oops. They have an infinity in here. Simple. Thank you. There it is. And this could just be 5. Thank you for getting me on that. 5. Let's just see what we get. Okay, yeah, it makes sense. So, and that last one, I don't, how else would you know? It's just kind of, I was guessing myself, but I would think number 10. Sure. Same question. What about it? Okay, and that could be because whenever they have these red numbers, that means it's going to be different for you and me, and everybody's got different numbers there. That's randomized. So yours might have been a 0.1 or whatever. So yeah, so but it's still do the ratio thing. That we're all going to have t squareds. Those are going to cancel. So it's going to be 1 over whatever this number here was. So yes, in fact, use a calculator, because sometimes when you just think you know what you're doing, you don't. And yeah. Make sense? Does that help? Yes, sir.
How would you know the last one?
I guessed. I'll be honest. And I just said that even though in business when we say it's indefinite, we use infinity mathematically. We know that in a business situation, we can't really go much more than 10 years, 15, 100,000 years. I don't think so. So what infinity really means in math, and we're using it in a business case, that's why I went with no. But I didn't have any book to look at. If they would have said yes, I would have called them, I don't know what I would have called them, but I just couldn't see it working. But some of these are just kind of give it your best guess, and that's why sometimes by getting an answer wrong, then we could talk about it and learn from it. But you'll see they do this a lot in business, and that's, in fact, when they were doing this, I go, how can you go to infinity? That doesn't make sense. I can go a few years out, I can go 100 years out, but not an infinite number of years out. But they do this in business mathematics because we don't know the end, and we just kind of see what's going to happen. Okay? All right. So let's, and again, we'll have, Thursday I should be back in. I've got another appointment on campus earlier. So I apologize to anyone who came to office hours. I wasn't there. Hopefully I'll make it home safe, but had a headlight blowout and the replacement has already blown out. So it's an electrical thing. We'll see. So we're going to take a look at this part on average rate of change. Okay, so what does an average mean? How do we calculate an average? Got 5 numbers, add them all together, divide by however many we have, right? So if I have 5 numbers, I divide by 5, right? So that's kind of the idea of an average. What we're doing with average rate of change, though, is we're seeing how things are changing, so going from one point to another on average. So we're going to calculate change, we have to subtract, right? Not just add. So we're going to subtract the 2 points. And for average rate of change, it's a ratio of the change in x, the change of y. Let's see. Which you might, if you go back to your algebra, and there's actually one of the slides in here, but I kind of want to I want to tell you in advance, this is all we're doing. We're getting the 2 points, so the y values, we're subtracting them, dividing by the x values. So slope, right? What we would think of as slope. But what we're going to do is we're going to apply it to functions that are not linear functions. So instead of calling it slope, we're calling it the average rate of change because it's not necessarily the same everywhere in a function. So that's the example we're going to look at today. But for most of this lesson, if you understand y2 minus y1 over x2 minus x1, it's going to be, that's what we're going to be doing. We're going to do a lot of calculations. It's setting us up for Thursdays where we're going to take a look at, like I told you, combining that with the limit and making it so that the 2 points come together so we don't get average rate of change over this interval, we get instantaneous rate of change. So this is sort of the first step of it. And hopefully you find this fairly straightforward. You'll see things in the homework. They'll give you some kind of data. And we'll have an x value and a y value, or input and outputs, right? And this is for Center Force stock market index during this period. So T equals 8 represents 2008, so 2008, 2009, 2010, and so forth. And these are the index prices. We see it going up. Not necessarily linearly. In fact, actually, it's not always going up, is it? So from 8 to 9, it actually went down, then it went back up. So we're going to take a look at this and ask a few questions. So the first question that they're going to want to take a look at is, what was the average rate of change over the 4-year period 2010 to 2014? And then they want to see from 2008 to 2010. So they want to do some comparisons, and then 8 to 13. Now the slides, if you go through them, they will work it all out. We'll go back through there. What I'm going to do is I'm going to back up. You'll see this in your homework. They'll give you this. And so what do they want? They want it from 10 to 14. So they might list it like this. This is the interval they want, the average rate of change. So what do? We use the values for 10 and 14, and we ignore everything else. Okay, so we're just seeing what is the change between these two time periods. And this is what, sometimes I'll show you this method that I've used is if you list the point, the input goes first, the output goes second, and for the second point, in 14 years, the index was 1,800. Now you can set it up with that formula. So, okay, I'll take the Y values, subtract them in the top, and I'll take the X values and I'll subtract them in the bottom. You have to be careful that the Y values and the X values are above each other, because if you get them in one of them in the wrong order, you'll get a wrong sign. The other problem I have with this is oftentimes the tables are giving us with the X on top and the Y on the bottom. When we go for average rate of change, the Y is on top, the X is on the bottom. So I picked up this, again, I study ethnomathematics, math from various areas, and I picked up this technique from ancient India. They do something called vertically and crosswise. So I line up the points and then I get to just subtract them. So 10 minus 14 is negative 4. 1,150, subtract 1,800 is going to be negative 650. Okay, good. And then so this is the vertical part. Vertically subtract down, and then crosswise you take the X and tuck it underneath the Y. So it's just a different way, and again, with dyslexia, this is the way I typically will do it, because when I line things up, I have problems. I'll just put it that way. I don't get, and so if you're lining up these with that Y2, Y1 minus X2, you're fine. But if you get things scrambled from time to time, if you go here, so I get about 75% right over there. I get about 99% right over here. I still mess up a little bit, but and then we can right. How many times does 4 go into 650? Anybody? How much? 162.5. Okay, and the units are going to be points per year, right? So that's the other thing we pick up, because in business we need to make sense out of what we're dealing with. So on average, what we can say is that there was an increase of $162 or 162.5 points for each year. Now we look at this and we see there was a year where it was kind of level, so it didn't actually increase each year, but that's what average rate of change gets us to think about, is that on average it would have gone up 1.62. Some years it went up more, some years it didn't, but on average we could just look at that. Okay, so that's all the average is getting us, is an average rate. Again, it's kind of a crude measurement, right? Because it's not actually what happened, went up and it went down, and that's often happening, but sometimes we just want to know on average. Okay, what we're going to be able to do is get the calculus pretty soon and get instantaneous rate of change, which is a much more powerful business tool, because then it helps us make some decisions, you know. This is maybe for long range planning, right? Over 4 years, this is what happens. Okay, so sometimes we use this average rate of change. It's not that it's bad, it's more for long-term planning. But if I got to plan what I'm going to do tomorrow, I want to have instantaneous rate of change, and that's what we'll pick up. That's where we're going with this. So far as the calculation itself, is it feeling comfortable, good? And again, any technique you want to use, you put it in the calculator. There's a slew of questions that they give you a table and they ask you for average rate between two particular points. And again, that's all you're doing. The other one was between 8 and 10. And so for that, we would do exactly the same thing, but we would just pick these 2 points. We'd find its average. And again, I'm going to go through the slides now because they do the calculations for us, but that's all we're doing with average rate of change. And then they're going to do the graph. Again, nice, they did it for us. So again, they line it up too. So they're doing the change in the points, so 650 change here. So it went up by 650, and then the number of years was 4. So yeah, 14 minus 10 is 4. When you do the division, 162.5 points per year. So, but if they give you units, also try to focus on coming up with the ratio, what the ratio of the units is. Because that, again, is really going to help you as we get into more word problems down the road. Okay, so the change of the points divided by the change in time is what we're calculating. They're setting it up with function notation. Again, this is easily adapted. This could be written as y2 minus y1. Took those out of there. And x2 minus x1. And again, we can use any variables we want, any letters. There we are. Okay, same thing. You're going to do this maybe, I think there was 10 questions this time. So they have you do maybe 6 or 7 of these like this. And then interpreting the result that on average, the index went up by 162.5 per year on average. Again, it's not what actually happened, it's what, if we want to look at things long range. And then they'll do the same thing going from 8 to 10. Again, step by step. You're just using the different values, right? You're using the values from 10 and from 8. And we see that actually from year 8 to year 10, it actually went down. So that's when we're going to get a negative value. And that's the key of making sure you get things lined up right and going in the right direction. And again, dividing it by 2, we get 125. So from 2008 to 2010, it went down by 250 on average per year. Again, it might not be exactly what happened. It might have gone down a lot more the first year and then came back, but it just tells us over the average, that's what's happening. Okay. And then 13 to 8, so 8 to 13, again, we do it, actually, if you look from the start of 2008 to 2013, they both ended up at the same value. So you just say it never changed. On average, it never changed. But if you were investing in this, there was some times where actually you lost money, you came back, and so in the end, what really happened, it doesn't give this picture. Well, that's a 5-year time period, no change. But there was change on average, no change. But in between, it was a pretty rocky ride. If anyone's been into following the stock markets over this last year, since COVID, it's been a rough ride. But as I think I mentioned, I used to be in financial planning, and what we did is if you look at the stock market in larger terms, 20-year rolling terms, the stock market has never lost money in any 20-year period. It's a 20-year rolling average. Doesn't mean there was some stress in between there, but if you're willing to set in, and so I put my retirement stuff in kind of more risky investments because those get better returns in good times. They also have more negative returns in risky times, but I'm trying to make up for lost time, so that's what I do. I take on that risk, but I have that faith that in a 20-year time period, I will get back. And hopefully that happens. Now, like we talked about, long term, can we say that's going to happen? Well, you know, who would have seen the world coming into a war and this recession? And so, you know, 2 years ago, it looked like, oh, once we get past COVID, everything's going to be cool, right? We're going to, and then other things are hitting us. So long-term predictions are hard. But if our economic systems continue to work, and again, we had World War II in there, we had World War I, we had some pretty bad stuff going on. But over time, human society seems to recover pretty well. And we even had like, what, the late 1919s, the Spanish influenza, so we seem to recover, and that's one good use of average rate of change is for investors. Sometimes if you're going to, especially if you're doing risky stuff, you might need to be willing to sit it out. Okay, questions so far? You doing okay? So then again, what we're going to look at is, so this is if we graph it, we see, yeah, there is change. It's changing all the time. From here to here, it looks like there's no change, but there was probably some white knuckles of, are we going to get our money back, right? And then if you held on, you got up here, you got a nice return, you know, 'cause that, again, that's increased value to your investments. But if you got scared here and sold out, you would have taken the big loss, right? That's one of the things that you need to be, when you do any kind of investing or running a company, you have to be paired with the sort of the risk tolerance you have. If you don't have much risk tolerance, you shouldn't, you gotta be careful of some of the investments you're in. You have to be, okay, I took a big loss, but it's a paper loss, I'm just gonna wait it out. Yeah, I waited 5 years and it paid off, but there are guaranteed investments, but usually they're much lower returns. Okay, so you gotta kind of decide there. But that's the idea. We're using this average rate of change is just between two periods in time. Sometimes it doesn't really give us the full picture of what's going on, but sometimes we don't have that full picture. Okay, and sometimes we do have the full picture, but we want to see, okay, how much time do I need to give myself so that on average I'm always, you know, making something on my investments. If I just stick it out, how long am I going to have to wait? And I think, if I remember right, it's about 7 or 8 years is the longest time period of sort of continual down. So if you're at least got a 7-year time period, you could pretty much stick with almost any investment and make it through. Yeah, any sort of not too regulated. I don't know about Bitcoin and those kind of things right now, but okay. So again, just finding the average rate of change. So all these different things, and then they're going to show us graphically what that looks like. You know, so if we did the average rate of change from 8 to 10, if that would have continued, it would have continued going down, but it didn't change, you know. So with algebra, oftentimes we start thinking in as a linear equation, but when we're thinking of average rate of change, we're thinking it's just between two time periods, and we have to be careful between which two time periods we pick. If we use that to project off, we may be very much off. Okay, so average rate of change has its uses, but long-term predictions can be very, very far off. And that's what, you know, whenever, you know, when people are complaining, oh, the economy's going down, there's nothing you can do, you know, things change. And when things are going really good, remember, things will change again. So you got to be prepared to be wealthy, to be poor, but be happy with your life, and because things are going to change all around us, and that's the thing. Okay, so We're going to look at now using, if we not necessarily just have data, but if we have a equation, a formula. So how do we do that? And again, it's really going to be the same thing. It's just that we're going to have one more step in our calculation. We're going to need to probably plug the function into our calculator, have a table of values give us the two y values that go with the x values, and then we come back and do the average rate of change formula. Okay. So again, they're formalizing things a little bit more for generalization. What average rate of change is in function notation. I guess I should look over here. You know, it's the y values being subtracted in the top divided by the x values in the bottom. And so they start using letters A and B for the point. You know, the x values, here's A from A to B, and then you get y values, and then we're going to calculate those average rates of change. Nothing really any different than what we've been doing, but just some notation. But just sort of get used to the notation that we're going to get, because we're going to use some of the similar notation as we start getting it ready to get instantaneous rate of change. So it's a tool we're going to use. We're going to put in last week's topic on limits, and that's really the only reason we talk about limits, because we use it to get instantaneous rate of change. And we go there. Okay. So on a graph, with this particular given function, again, it's a curvy function, to get the average rate of change between 2 points, we're getting our 2 points, and we are getting a straight line average, right? It's not what's actually happening, but it's what's happening on average between point A and point B. They may be times. We call this a secant line. And again, you weren't required to have trig for this, but there's a function in trig called secant, and it is related to this, and that's opposed to a tangent line. So a secant line touches a graph in 2 points, like this. We're going to move into what a tangent line is, and we'll start working with a tangent line on Thursday. Tangent touches it in 1 point. Okay, so that's where we're going, is we're eventually going to get a technique to move these points together so that we can get the rate of change instantaneously at the point. But that's what all this is saying. So, but when we're dealing with average rate of change, it's always a secant line. And again, it's a word that comes, I believe, from Greek. So it's not real familiar to us in our everyday lives, but just a secant line is taking 2 points, and it's going to give us average rate of change. Okay, so if you see secant line, you know you're getting an average rate of change. The tangent line is what's going to give us the instantaneous rate of change. Okay, and again, they just give us a quick example. They're giving function values, so when you plug in 3, f of 3 gives us 1 billion. Let's see, did they give us, I think it's, the next one we're going to see, they actually give us the function, so I'll show you how to get these values. But if they give us the values, x is 5, y is 0.5 billion, then we can just do what we've been doing so far and finding an average rate of change. And again, remember, these are just 2 y values being subtracted on the top divided by the 2 corresponding x values being subtracted on the bottom, and it gives us an average of 0.75 billions per year. So how it's been changing. Again, it's maybe not accurate of what actually happens, but it gives us over this time period from year 3 to year 5, on average we increased by 0.75. Now this is where we're going to start. I hope in the homework they don't have you start with this yet, but this is getting you set up for Thursday's lecture. We're going to be using this a lot. So far, we're going to just use some specific values, but what this is instead of thinking going from A to B, what we do is, I should look over here. We've got A, and then we, instead of calling it B, we're going to call it A plus some distance, okay? So that's, it's really still B, If you want to call it b, you could call it b. But if we call it a plus some distance, now it's a little bit more movable, because we could reduce that distance. It could be a plus a smaller distance and bring them together. That's the technique we're going to use. And notice what the problem is in the bottom, you just have h, but let me show you the step before this. What they would have had is f of a plus h, right, minus f of a. And they're saying that b is a plus h. In the denominator, what would be? It would have been a plus h minus a. That's the slope formula. But notice, what is a minus a? 0. So it goes away and there's just an h. But this is what got me, I struggled so much with thinking about this. I couldn't see this as the slope formula, because this doesn't look like two things being subtractive. It's just that when we subtracted them this way, a disappears, because a minus a is 0. But just, so I would encourage you, maybe write this down a few times, and that'll get yourself maybe more comfortable thinking this is just slope, and part of it is disappearing, and we're just getting h, because every time I look at it, it's hard for me to think of this as a slope formula, right? Because I don't see 2x's being subtracted. Oh, here it is, and then it disappears. And then after a while, you get a, well, I still am not real comfortable with it, just to be honest, but I still go back and remind myself that that is what they call it, the difference quotient. It's really just an average rate of change, okay? But we start using it, what we're going to do is we're going to make h, that distance between the 2 points, we're going to make that go to 0. And notice, if you let h go to 0 here, do we have any problems? We've got division by 0 problems, right? So there's going to be some techniques we pick up on Thursday for this. Okay, so that's just kind of a prelude to what we're going to do. Now let's look for some specific functions. And again, the only thing we're going to add here is we're going to be given a actual function, an equation. And when we're going to want to find those y values, what we're going to do is we're going to, I mean, you could plug in the different values for t and manually do it. What I like to do is just put it into my calculator, graphing calculator, and use the table to get it. So we've got this function, which is the price of an ounce of gold is being modeled by this for between 7.5 hours and 10.5 hours. Okay, quadratic is going to have a curve to it, some part of it, right? Let's see what the next one. They graph it for us, right? So we see it's not a straight line function, but we could get an average rate of change between any 2 points. Again, we're going to use this as our function, and then the question is going to ask us to find what was the average rate of change of the price of gold over the 1.5 hour period starting at 8 a.m. So t is equal to 8 going to 9.5. So again, they do work it out, but I'm going to show you how I would do this with the graphing calculator. Let's keep this for now. So let me, oops, not that one. Yeah, almost there. That shows up okay. So I put in the formula. Put that over. 5x squared, because that's what the calculator uses. Arrow over, minus 85 x plus 1762. And then what I would do is I'd go to the table, and we're looking for when x is, actually let's If I go to table set, I've currently got it set up on Ask. I'm going to set it up. We want to go from 8 to 9.5, so I'll start at 8, and I'll have it change by 0.5, so that when I go into the table, and again, you could do this multiple ways. You could just leave it on Ask, but when at 8 a.m., this function says that the y value was 14.2. Let's see, why does it disappear that way? And then at 9.5, it's 1405.8. So those are our y values we're going to use with those particular x values. But that's how I would use my graphing calculator, get the table and find, 'cause that's the first part of the homework. They give you the table, right? Second part, I think there's 2 or 3 of these, they give you an equation. Just put it in here and you get the table. Okay, and then it's just like what we were doing. So 1402 and 1405.8. So I'll return back here. So we have the points 8 and 1402, and then we had 9.5 and 1405.5, was it? Anyone remember? 1405.8, okay. And again, we just do our average rate of change between these two, recognizing it's not actually exactly what happened because it was not a straight line change, but on average, it would have changed. The price would have changed by that amount per hour, right? And I think I'm just going to continue with it because they actually do it. Another way is you could actually plug the values into the function, but to me this gets too much detail into it. And in business, you want to be able to understand what's happening on the detail level, but at the same time, you want to get pretty clear data. And that, to me, when I do this part, I get bogged down. And notice we got ours rounded it to 8, but okay, you could get this. But using the table, using the technology, the 2 values we needed was that 9.5 had a value of 14.575. And so if I get a technique that gets me to do that, it allows me to stay on track with my decision-making process of just the data I need without having to get too much into the minutia of the calculation. But if it's helpful for you, again, each person's different. If it helps you to understand what's going on by actually plugging it in and get it, you can do it that way. But over time, I think you'll get to the place where you'll trust the calculator and you'll put it in and you'll get these 2 values. And then once you've got those 2 values, we just do the calculation, right? Subtracting these, 9.5 minus 8 is 1.5, and we get 3.75 over 1.5, which is about 250 per hour. So it was changing on average about 250 per hour between those 2 time periods. Okay. Again, that's not a very good way to try to predict what's going to happen the next one because things change, especially in the gold market. Okay, you got to know what you're in. But sometimes you want the average rate of change. Okay. That's the last slide. They're close. My calculator, because of space, rounded 0.75 to 0.8. So but that's a good thing. What I should have done, or what I could do, is on the calculator, it does say 1405.8, but if I go over here, it shows it unrounded, because you might need it to get it right, because it might be the thing that makes it wrong on the,
I'll write it down.
okay. Yeah, and depending upon what you've got going, so sometimes if you want to get the exact values, actually come over to the table and it'll give it to you down here. There's also probably a way to format the width of it, but, okay. But that's what, get comfortable using the graphing calculator. But again, if that's another level of discomfort for you, you can also get it by plugging it in and doing those things. But one of the things that will help you as you go through this course is to use the technology to do the nuts and bolts calculating as much as possible. And again, that question at the beginning, 1 over 0.2, I thought I knew what I was doing. If I just used the calculator, I'd get the right, because a lot of times you think you've got at least this is me talking, I think I've got the right calculation, but if my calculations initially were wrong, all this other work I did, I think I got it wrong, but it was like an arithmetic thing at the beginning. So that's why I like to double check everything with calculators. Okay. And that's our lesson for today. But as you do this, and again, and you'll see in the homework, it's just a couple of tables, find these average rates of change. They'll give you a couple formulas like we just did, average rate of change. Thursday, we're gonna move that a little bit and then say, well, let's get instantaneous rate of change, and we'll take that next step.